Welcome to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Ram Wissel.
Hi, thank you, William, and good morning, good afternoon, good evening. Thank you for tuning in to today's Tech to Tech session. I'm excited to talk about this is part of our Vapor Degreasing series. What do you need to know about PFAS? What is that, and why are we starting to hear more about that term? So, really, I'm going to start with the question of what is a PFAS, the new four-letter term. Per and polyfluoroalkyl substances. A bit of a tongue twister or mouthful, so it's abbreviated just as PFAS. So what it's but really, what is that? Well, it's not a chemical. It's really more of a large group of these organofluorine compounds. You look at the tree here on the right hand side. You may have heard about PFOSs, PFOA materials, perfluoroalkyls, but what we really these are all different species of PFAS materials. There's estimated to be more than 5,000, depending. You might see 9 or 10,000, depending on where you Google. Just different synthetic substances that could be considered of this PFAS chemical group. So we still really haven't defined it. So what is a PFAS? And these are materials, and we're not going to go too deep into a chemistry lesson. But these materials contain a chain of carbon atoms bonded to fluorine atoms. And it's important because these carbon fluorine bonds are some of the strongest in organic chemistry. And so if you look over here on the left-hand side of the slide, you have an array of 8 carbon atoms, and these green dots at the end are the fluorine. You can see how there's fluorine attached to the carbon. And then you have some other things off at the end, and that's what separates the different molecules. But this is the PFOA, the perfluoroalkyl acid structure. Normally, these materials are, 8 to 7 or 8 carbon molecules in length, but they can be anywhere from 2 to 16 are normally considered PFAS. But that fluorine carbon bond makes these things extremely stable in the environment, and that's why they're called forever chemicals. And we'll talk a little bit more about why that's important on the next slide. These materials can bioaccumulate over time, and whether they're used in an industrial application or consumer goods, uh, firefighting foams, for example, they go into the wastewater streams or into a landfill. Because they don't break down, they can then make it back into the environment and actually into the food supply. So PFAS materials have been detected in soil, in groundwater or drinking water, fish, and wildlife. And there's even 12 species that have been there, 12 types of PFAS materials that have been detected in the human bloodstream. And so, these chemicals that might get into our body, what's some of the potential concerns? Well, the CDC says that the human health effects from these materials are still uncertain. They've done some studies with lab animals and given large amounts. Again, this is much more than what you would normally hope to accumulate in your human system. May affect growth and development, or you may have some other reproductive, thyroid, immune system, or liver function issues. So they don't know, but we just don't want these chemicals to really get into our bodies, and that's why there's a lot of focus on this topic. So you might ask, well, do I use any of these PFAS materials? Well, they have a lot of valuable properties. They're very durable, they repel water, they're great for heat resistance, and again, we're going to talk about that chemical stability. So I like the graphic on the right because these are some we're thinking normally about the cleaning or the manufacturing industry, but there's a lot of things that are around the house that we may use every day that contain these PFAS type materials. Nonstick cookware, the Teflon coatings on that, water resistant clothing here, Scotch Guard, things that you would spray onto that. Because they repel water, they're great for that type of application. Um, Pizza boxes, microwave popcorn bags, things that you don't want to get saturated with that. Some of these materials can be used as surfactants and paints and varnishes. Talks about dental floss, that might be coated with a Teflon or Teflon-like coating. They're great for stain resistance. So there's a lot of things that we use every day. And again, just kind of going back to the example of the Teflon coated pan, we've all used those, and you can scratch that coating off. Well, where does that little bits of material go, and do they ever break down? So, really, we think of PFAS materials as a global concern. However, there are critical applications that rely on these fluorinated materials. A couple that come to mind are medical devices. A lot of things in that operating room, or just in medical applications on a day-to-day basis, rely to be on sterile or chemically inert tubings or different materials. Military and aerospace and semiconductor production. It's really hard to do some of the advanced applications without chemically inert materials, hoses, tubes, fittings, that sort of thing. So, what kind of about our industry? I'm not going to go into this in the short time entirely, but the 3M just before Christmas released on December 20th, 2022, that they were exiting the manufacturing of PFAS by the end of 2025. There's a link to the press release. You can Google it. But basically, they will discontinue manufacturing all fluoropolymers, fluorinated fluids, and PFAS-based additives by the end of 2025. This is significant, and time is going by really fast. So the end of 2025 is just around the corner. So what are some of these alternative solutions for using a material like that? Well, since we're talking in the vapor degreasing series, these PFAS degreasing materials, may be an HFE or an HFC. There's some different alternatives, and we're going to talk briefly today about HFO solvents. There's vacuum vapor degreasing applications, and then there's aqueous alternatives or aqueous cleaning. As part of the ongoing KYZEN Tech to Tech series, some of these will be talked about in greater detail or have already been discussed, such as several topics on vacuum vapor degreasing and aqueous cleaning. So I would encourage you to tune into future or go back and look at previous Tech to Tech sessions for more details. But what I want to talk about today briefly is this hydroolefin technology. And I like the chart here on the left. We're back in the 80s. And you think about Freon, and what kind of put the hole in the ozone layer were these CFC materials. As they got phased out, there was a transitionary period where you could go to the HCFCs. Those had some trade-offs, although they didn't put the hole in the ozone layer. They had global warming challenges and more greenhouse concerns. So it transitioned in more into the HFCs, which are now being phased out, and the HFCs and now the HFEs, which are considered these PFAS materials. So HFOs are the latest in the series of vapor degreasing or solvent cleaner, more environmentally friendly solvents. And the example here with our product has an atmospheric life of 27 days. It doesn't sound like a forever chemical. It can be VOC exempt. And then they typically don't accumulate in groundwater. So again, just changes in solvent technology as the world has evolved since the 1980s and trying to become greener. We think about compliance a little bit. As they learn more about these PFAS materials and they start making different policies and regulations and laws. I want to talk about this TSCA Section 8, A7. This is done by the EPA, Reporting and Recordkeeping Requirements for PFAS materials. And I'm not going to read the whole slide, but if you just highlight here at the bottom, the EPA proposes to require persons, companies that manufacture, including import, or have manufactured these chemical substances in any year since January 1 of 2011, going back 12 years, to electronically report information regarding PFAS uses, production volumes, disposal, exposures, and hazards. They're trying to really just get a grasp on how much of these PFAS materials are in the environment and how big of a challenge that we're looking at. But going back and reporting production or importing of these materials for the last 12 years could be a monumental task. So that rule has not been implemented yet, but it may be up for a vote or adoption later this year in 2023. We talked about maybe 5,000 or 10,000, up to 10,000 different materials. But the EPA right now has a TSCA Section 8B chemical substance inventory. They're really looking at, go back, identified just over 1,300 different PFAS materials that may be covered by that rule. That was back as of April of 2021. If you go on the EPA website, they have about 430 different materials right now that you can look at that they're most focused on with different CAS numbers. It's mostly here in the US. What are we talking about, or what's going on in Europe? Well, the ECHA, which is the European Chemical Agency, just received a restriction proposal from 5 nation authorities, including Denmark, Germany, Norway, the Netherlands, and Sweden, where they're looking to greatly restrict or ban the use of PFAS materials. That proposal should be published any day now. They're looking to ban these materials or greatly restrict their use in production. We hope that there will be some exceptions, again, for applications around military aerospace where there's not an exemption would be required because of national security or greater need. But they're talking more, I think, about removing these materials from your pizza boxes and day-to-day use consumer materials. So when we really think about this, PFAS right now is a global concern being addressed very locally in different countries, different communities, certain states are trying to pass regulations. So as this year goes forwards, I would encourage you to pay attention to PFAS. And if you have questions about it, and this leads into our questions and answers. The first question is really, how can I check if a material I use contains a PFAS? And if you look at a safety data sheet, Section 3 will list certain CAS numbers, and you can go online and look those up. But the best thing to really do is just to contact your chemical supplier. They should be able to help you answer with confidence if that material that they're providing you with has a PFAS component. The second question is, we talked about, PFAS materials getting into the environment, into drinking water. Can it be safely or effectively removed? The answer is yes. Filters containing activated carbon or RO, reverse osmosis systems, sometimes you'll see those under the counter applications, have shown to be effective in removing PFAS materials from drinking water. So that's a positive thing. Are all chemicals that contain fluorine a PFAS? Absolutely not. These PFAS materials, again, have a very specific organic carbon fluorine bond structure, which make them those forever chemicals. And we think about, I'm going to go back to Teflon for a second. Teflon's more of a polymer that's thousands of molecules, usually thousands of molecules, carbon strings long. It's not, by definition, normally a PFAS because it's a longer chain than just the 12 to 16 that normally they're less than. However, if you burn it or as it decomposes, if it's burnt, those can break down and become those smaller things, so smaller chains. The last question here is the fluoride in my toothpaste okay? And again, yes, that's a different type of fluorine, just like the third question. Fluoride toothpaste is more of an inorganic. It's not the carbon bonded structure. Therefore, it has very different properties than being a traditional a PFAS material. So with that, again, I thank you for attending. And if you have other questions, please reach out to your KYZEN representative. And with that, I'll toss it back over to you, Will.
Thanks, Ram. And thank you guys for tuning into this Tech to Tech session. If you'd like to discuss this topic further or have any questions that were not answered in this session, please contact your local KYZEN regional manager or send an email to tech@kyzen.com, and we will have someone follow up with you as soon as possible. Do you want to have exclusive access to future content sent directly to your inbox, or do you know someone who would benefit from these sessions? If the answer is yes, just go to tech2tech by kyzen.com and fill out the subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.